A statistician can have his head in an oven and his feet in ice, and he will say that on average, he feels fine. That's a mean joke. Get it? You might get both jokes after this lesson. So we're going to look at describing distributions numerically. So I'm going to go ahead and take a look at some data. We asked some elementary students how many pets they had, and here are their responses. I'm going to go ahead and do a dot plot. It's not really a numerical distribution, but it sure does help to visualize the data. So here's the dot plot. I found a cute little applet where I enter in the data, and it just starts lining the dots up. So when I put in all the data that you're seeing up there, you can see the dot plot for me. Okay, so this is how the data looks. How would we describe this data? Well, we could look at where is the center. If you're looking at this, how could you say where the center is? Well, let's go ahead and put the original data in order and look for the one in the center. That seems like a reasonable way. So I'm going to cross off pairs of numbers until I get to the very center number, which is 2. Okay, so this is the point where half the data is above it and half is below it. This is known as the median. So in this example, the median is 2. What if there are 2 points in the center? Well, if there are, go ahead and find the number that's halfway between them. And if they're the same number, then it's no big deal. If you have 2 2's, for example, if I had an extra 2 here, then it would still be 2. If I had an extra 3 here, it'd be halfway between 2 and 3. So now I want you to try it. We're going to roll 2 die 10 times with these outcomes and go ahead and determine the median. Hopefully your answer is 8.5. So you can pause it if you need to work here. And I'm moving on. Is there another way to describe the center? Well, we looked at kind of just putting everything in order. Maybe we could use the same method we use to calculate your grades, which is take the average. And how do we do that? We add up the values and divide by the number by n. So in this case, we would add up all those points, divide by 15, and get 3. In statistics, we call it the mean. All right, and it's not just because some people think statistics are mean teachers. We call it the mean, and it is the same as the average. And on your formula chart, this is what you're going to see. X bar equals, and this funny looking thing here is called sigma, which means sum of or add all of these up. These are the individual data points. So this is X bar, or the mean, equals at the sum of the data points, add them all up, and then divide by however many data points we have. So go ahead and you can pause this and see if you can find that the mean for this set of data that we had before for the 10 die rolls is 7.8. Now, we just looked at both centers. Shouldn't they be the same? Well, the mean is influenced by extreme values, like this one here. So you could say that this one student with 9 pets is definitely bringing up the statistic. The median, on the other hand, is resistant to extreme values. It's just saying how many are on the left and how many are on the right. A distribution is symmetric when it looks like you could fold it in half and it would match. So roughly symmetric means the mean and the median are going to be close together. Exactly symmetric is when they're the same. And it's skewed, that means the mean is usually further out. So in our example, 3 is the mean and 2 was the median. So you can see 3 is already the mean's getting a little further away. Now we could look, besides looking at the centers, we could look at the spread of the data. So one measure, which you learned a long time ago, is range, and it's really simple. All we do is go max minus min, and that gives us a range. The problem is it's influenced by outliers. So that little 9 there is really changing our range. Don't you think maybe over here is a better value? So we're going to go ahead and try medians because those are resistant to outliers. So how am I going to do a spread with that? First of all, so before I do the medians, I'm going to do the range for this set. Sorry about that. And your answer should be 9 when you do it. So now let's go take a look at those medians to calculate the spread. And the other way to measure this is called quartiles. The lower quartile, Q1, is the median of the bottom half of the data. The upper quartile is the median of the top half of the data. And if there are an odd number of values, you're actually going to repeat the median. So let's bring back the example we were working on. So here, I went ahead and put these two 2's in red because originally I had 15 data points, but I want to have the same number for the lower set as I have for the upper set. So if I don't repeat that number, I'm going to have less for one of these. So I have 0, 1, 1, 2. So there are 8 data points in the lower data set and 8 data points in the upper data set. If I look at the points halfway between for this lower set right here, it would be these two 2's, which just happen to match. So we're going to call this the lower quartile, or Q1. And then the one that's halfway in the upper data set is 4. So that's the upper quartile, or Q3. So Q1 is 2 and Q3 is 4, which does make it interesting because one of the quartiles is the same as the median, and that can happen. Okay, so the main reason we do quartiles is so we can calculate the IQR, or interquartile range, and all you do is subtract Q3 minus Q1. In this case, we get 4 minus 2 is 2, so our interquartile range is 2. So go ahead and try it, and you're going to do it with the same die, and you should get answers of 6 for Q1, 10 for Q3, and your interquartile range is 4. So let's summarize. These are the 5 numbers you've learned to generate. The mean, you've known how to do that a while, and actually the median you've been doing for a while too. The lower quartile is new for you, as is the upper quartile, which is Q3. And finally, we also learned how to generate the interquartile range, or IQR, just by subtracting Q1 from Q3. We're going to be using the 5-number summary to generate box plots. So that includes 3 of the numbers in red here, plus 2 more. First, we start with the minimum, then the lower quartile, the median, the upper quartile, and the maximum. And using those, you could actually start with the median and go different directions. But basically, this is what is going to make your box on your box plots. This Q1, Q3 median, and this minimum and maximum are important as well, with some caveats. So why don't you go ahead and practice. You're going to use data for travel times and minutes to work, and here's the data. It's also available on the web page. And practice calculating to see if you can get the following for the 5-number summary. Min and max should be pretty easy. Get the median, the lower quartile, and the upper quartile. And go ahead and see if you can calculate the mean, oops, that should say mean, and the IQ.